What is up, guys? I know I haven't been posting in a while, but we have a big time severe weather outbreak possible. As you could see, the Storm Prediction Center, as of recording this, put out a moderate risk of severe weather. And you may be thinking, a moderate risk of severe weather is pretty rare. Indeed, it is rare. But you may be surprised, this event for once is not driven by a tornado threat. There is a small isolated 5% chance of tornadoes, but besides that, not much of a tornado threat, which is a good thing. Maybe it could get upgraded to 10%, but that's kind of unlikely. Our big factor is a 45 significant chance of 75 or 65 knots wind gust and a hatch to 10% higher probability. And as you can see, that's near the Oklahoma City area. They're actually in the 30%. I wouldn't be surprised if this moderate risk gets a little more pushed east, like a tiny bit more pushed east there. I wouldn't be that surprised. Wind threat's the main concern. Hail threat is pretty low too. And so now let's get into the model. So these are the models. We're going to first be getting started with the reflectivity. So as you can see, right now there's nothing all the way up to 25 hours out on Sunday. So that's 1 p.m. on Sunday about. As you can see, these are like just showers. As you can see, the cold front line starts to come here. As you can see, by like about 5 p.m. Eastern, these storms start to form near Texas, northern Texas, the panhandle of Texas. And then as the hours go, we are also going to be looking at the HER model, the other model. So you would have a different perspective. By like 8 p.m. or 7 p.m., a big line is going to be produced with possible 75 miles an hour hurricane force winds possible. We got all that stuff. Hail possible, isolated tornadoes in the QLCS line, isolated tornadoes there. As you can see, it starts to like weaken a tiny bit as it gets to, but then there's like this band down here. And as you can see, this is about 10 p.m. or 9 p.m. And this is about 11 p.m. The line starts to weaken at 11 p.m. Eastern, 10 p.m. Central. And as you can see, the line still, as the overnight hours, it starts to weaken and become a weaker line. And sorry, my mouse was glitching. I have to go on to the next clip. And now we're gonna be showing the dew points. As you can see, dew points are gonna be actually lacking a little bit of dew points. You have to have 60 or above to sustain real thunderstorms. And as you can see, by like 23, we supposedly only get like 54 dew points. That's why we're not gonna see a very. And there's the dry line starting to kick in already. As you can see, eventually, this is the moderate risk area is only going to get about 50 dew points. But as the cold front comes in, they will be isolated 61-degree dew points. But unfortunately, it is a tiny bit too late. Because if we did see a tornado outbreak, which we're not, this would be way too late. Originally, I thought there was going to be more of a tornado threat, but it's actually more of a, I don't want to say possible derecho, but you never know. And now let's just see the severe weather parameters, like your CAPE, your instability. As you can see, CAPE is not high at all. You need about 1,000 joules per kilogram to sustain thunderstorms. And as you can see in the moderate risk area, we only have like 200, 300 joules per kilogram. That's why we are not going to see a tornado threat. And the line, this is where like the line comes in and it weakens gets rid of the cape all the way, basically. And now let's see your lapse rates. Your lapse rates are actually good in this event. Like, some events lack lapse rates, but this event is not going to be lacking I can't even speak lapse rates. But the difference between today's event is that the other parameters, like we're lacking dew points, we're lacking summer cape, and just good lapse rates wouldn't really like sustain them too well. Now let's view the lower level jet, if I could find it. 500 millibar watts. And then we're going to view all this with the HER model next. So this is basically the lower level jet. The lower level jet is actually going to be pretty much cranking at this time. As you can see, when the storms do get here, the lower level jet is going to be decently high. Or almost very high at this point, as you can see. Sorry if my dad coughs in the background. As you can see, the lower level jet is going to be decently high for this whole storm. And that's a little bit of a bad thing, because then your thunderstorms will sustain a little bit more if your lower level jet is high. And now let's view all this with a different model. And now we're viewing the HER model, which could be a little bit of a different scenario. As you can see, storms form at about the same exact time. But if you notice, to me, these storms, they're showing a little bit of, let's zoom in a little more. They're showing to me a little bit of, not as stronger, but to me they're showing a little bit of, stronger storms, as you can see. Do you guys notice how it's like a little bit stronger? Like I see more like hail. Like it's showing like a real almost derecho, this model. And this model is showing a little more than the NAM. As you could tell in Oklahoma, then it starts to shrink and then it exits. This model we gotta watch out. I think this model is what triggered the actual moderate risk, in my opinion. Now we're basically gonna view the same thing, but we're gonna be viewing the dew points, if you know what I mean. Now let's get the dew points out here. As you can see, the dew points, they're showing a similar thing, just a tiny bit more 61 degree dew points. That's what that's what the HER model is showing, a little bit more dew points, as you can notice. And the dry line is the same, because as you can see, go from 61 to 27 in just a few minutes with a dry line. Now let's view the cape. Surface-based cape. And let's see if this model is showing more or less cape. Oh yeah, guys. This model is showing more cape, like 700 to 1,000 joules per. So overall, this model will be like the worst case scenario. I think it's going to play off more like the NAM, though. As you can see, then the cape dies down. And now let's view the lapse rates. As you can see, lapse rates are less with this model. A tiny bit less lapse rates with this model. Now we're going to be viewing the lower level jet and see if it's higher, lower, or the same. Yeah, this is actually the same case scenario with a lower level jet. Guys, I hope you enjoyed this video, and I hope you guys could like, subscribe, and share this information with all your friends and family members, whoever's getting impacted in this event. And I just wanted to show you one more thing before we get off here. This is like the loop would look. See, you see your dry line comes. Dry line, also known as the cold front. As you can see, it clashes. And thank you guys so much for watching, and peace out.